This is a short video to talk about a large language model use case for the auto insurance industry. Let's look at this use case. Safe driving course discount. We are going to take a look at the use case interaction and point out some of the challenges associated with this use case, and then we'll talk about how large language models can help. First and foremost, customer has taken a defensive driving class and they are now eligible for a discount. They need to upload the defensive driving certificate, but they're not able to figure it out. So they call customer support, and the customer support helps them figure out how they need to upload the completion certificate. A few weeks later, the customer calls again because the discount has still not been applied. At this point, the customer now wants to talk to a manager because they have waited patiently for multiple weeks. It now takes 2 more calls to ultimately resolve this complaint. So at this point, we have fielded 5 or 6 calls to the customer support. At this point, we have effectively wiped out any profit for that term of that policy. So you might be thinking, perhaps this is a customer agent issue, maybe this is a training issue, but this problem appears to be more systemic versus an individual agent-based. So here are some of the challenges that made this interaction complex. First and foremost, the customer had to go through this additional complexity of finding out the approved training, then figuring out where to upload the certificate. Secondly, in order to determine the current status of their request. So maybe they uploaded the certificate, maybe the PDF that they uploaded was corrupted, maybe the certificate was valid, but the discount would only apply in the next cycle. So there is complexity in determining the current status of the request. Additionally, there's complexity, as I mentioned earlier. If the PDF was corrupted, maybe the discount was already applied, maybe the discount is going to be applied down the road. So the resolution to customers' question is hard to determine because we have multiple systems to talk to. As I mentioned earlier, there is some complexity in being able to resolve the customer's question. For example, the uploaded PDF may be corrupt or cannot be opened. The training that the customer took was not eligible in the state of residence. The discount is to be applied in the next billing cycle, which is why they don't see the discount applied already. The customer might already have a rate which makes them ineligible for any further discounts. So as you can see, there can be a number of factors that can go in satisfactorily answering customers' question. Let us now look at how large language models can help with this use case. You may already be familiar with large language models, but if not, you can check out the videos shown here on the slide for some additional background information. So let's just jump into how LLMs can help. So first and foremost, LLMs provide a natural way of interaction with the customers. So the customers can interact in a chat-based manner, which means there is less reliance on complex UI. LLMs also have a superpower of being able to comprehend text from multiple sources. So we can get information, as we will see shortly, from multiple backends. For example, we can get information from a log message. So our backend application may be emitting a log message, which tells us that this PDF that was uploaded was indeed corrupt. Language models can look at that log information and make sense out of it and provide a reply to our customers. They can also look at error messages that may come out of our business tier. For example, an incorrect defensive driving class was used. They can also look at some of the messages that flow between systems that tell us when the discount will kick in, what is the billing cycle, etc. So here is a notional design for integrating large language models in the use case that we have seen up until now. So here's the customer right here. Customer is interacting with the large language model in a chat-based manner, which is natural to them. So they're not dependent on some complex UI widget or a menu item, which tells them where to upload the certificate. In addition, we have this notion of retrieval augmentation. So large language models have been trained on trillions of tokens of text on the internet, books, etc. But they don't understand the knowledge within your enterprise. They don't understand the information coming out of your business systems. And this is where the retrieval augmentation comes into play. So you might have an insurance business services or a set of services, which in turn talks to things like the billing system, talk to things like the application logs, may also talk to applications like policy application. So the retrieval augmentation shown here is really retrieving information from these business systems pertinent to that customer and making that information available to the large language model, which is in turn able to take that information and provide a response to the customer. Let's take a look at a quick demonstration of using large language models, in this case GPT-4, to simulate the interaction with the customer here. I'm going to be using a collection of prompts. In addition to the prompts, I have provided some context information about one or more customers. Let's get started. So here I'm instructing GPT-4 to act as an insurance application that responds to customers about safe driving discount. Once the customer has provided information about safe driving certificate, we want to capture that information, convert that into a JSON message, and simulate sending it to a billing system. Let's get started. So here, once that prompt has been set up, I can come in and start interacting with GPT-4. I'm asking a question about safe driving certification, and it comes back with the detailed information that you can see here. This information, of course, is based on the vast amounts of data that it has been trained on. This is not something that I've provided. Let's go further. I come in and I say, I have now completed the defensive driving course, and here are the details. Here's my customer ID. Here are the details where the course was completed. And based on the prompt that we have set up, it responds saying congratulations. It converts that information into a JSON payload, and it simulates sending it to the billing system. So at this point, we can come in and augment the information that is already available to the language model with some information that we have gathered from the application logs or from system-to-system messages. So here you can see two log messages. The first message is for customer 123. This is suggesting that the discount has been applied and will kick in on June 30th. The second message is for customer 124. Even though the certificate was uploaded, the customer is not eligible for a discount because they are part of a policy that is ineligible for a safe driving discount. Okay? So we've augmented the context with these two pieces of information. With this data in place, let's take a look at how ChatGPT responds. So I come in, my customer ID is 123. Can you tell me what happened to my safe driving discount? And because it read the log message, it is able to successfully answer this question and say everything is good to go. Your discount will be available on June 30th. In the case of customer 124, it provides information based once again on the log message that your policy is not allowed to stack multiple driving related discounts, so you will not be seeing a discount from the most recent certificate that you have uploaded. So that concludes a very simple demonstration. Here you can see the benefits of this whole interaction. Customer is able to interact in a natural language manner. The large language models are able to read information from multiple sources, and through that augmentation, we are able to answer customers' questions.